Okay, yes, it's recording. Okay, Carter and Aubrey, I think, is who we're recording for. We're going to do number 24 from the homework, even though we haven't finished the notes yet, but I said you should be able to get through maybe like 30. Oh, we're delayed. That's okay. But we're going to do number 24 together in class here. They give you this information and they say find the other five trig functions. So I've got sine, I don't know if they call it theta. Do they call it theta? Or maybe t, I don't know. Tangent theta, cosecant, secant, cotangent, yeah? Okay. All right. Okay, we need to draw a picture of what this thing looks like. I get used to just drawing my triangle so that he looks like he's in the first quadrant. Remember I said that yesterday? Like you have this thing going on and you have your triangle kind of in the first quadrant, where angle theta just is that inside kind of like closest to the origin, yeah? Okay, cosine is what over what? What's cosine?
Adjacent over hypotenuse.
A over h, yeah. So which side is the adjacent side according to this?
Bottom.
The bottom, square root of 10.
Yeah.
The hypotenuse side is 10, and then we got to find this guy. Okay, which side is side C?
We gotta find that.
10.
Or 10. Okay,
10.
fine.
Let's do the square root of 10 squared plus b squared.
Not change the.
So it's the square root of.
I was gonna say.
It's the square root of like 90.
Yeah, that's what I got.
Yeah,
Is that right?
yeah.
Okay.
So the square root of 10 squared is just 10, plus b squared. The 10 squared is 100. If I subtract the 10 over, I get 90,
Call me.
and then I take the square root. Buh.
At the beginning, when it gave us the cosine thing, I changed it back to 1 over the square root of 10. Can I do that? From the 1 to the square root of 10.
Certainly. Yeah. Now hold on. I like your idea, Reese. Yeah, we're gonna get there, but we're gonna get there a little bit harder way,
Okay.
I think.
I wanted to get my. But I wanted.
No. Okay. The square root of 90. Don't make him a decimal. Are you guys listening to that? Don't make the square root of 90 a decimal. If I want to break him down, he is 9 and 10.
No, we don't want to break them down.
I'm sorry. 9 and 10, he is 3 square roots of 10, yeah? 3 square roots of 10? Okay, let's do that. All right,
Break them down.
next.
That's what I was wondering.
Yes, because it's going to cancel really nicely with the square root of 10 and square root of 10. It's going to be real nice, okay? So, we already know cosine is the square root of 10 over 10. Okay, that's what he is. Let's go secant. Let's figure out what he is if I flip him. If I flip him, he will be 10 over the square root of 10, right? But if you rationalize, like the square root of 10 will bump up to the top, so he will be 10 square roots of 10 over 10. Yeah? Do you see how that works? But then, the 10s can cancel. So he is just the square root of 10, yeah? That's what secant is. Do you see how that works?
Can you zoom out? Okay.
Okay. All right, now let's do our other stuff. So sine is OH, right? O over H. Which one's opposite?
The 90 thing. The old 90 thing.
Yeah, the 3 square roots of 10.
Yeah.
Okay, so the opposite 3 square roots of 10 over the hypotenuse is 10. Will he reduce? Can you cross those 10s out? No. Ugh, oy vey. Cosecant. Gross. If I flip that, is 10 over 3 square roots of 10. How do you get that square root of 10 out of the bottom? Multiply by what? The 3 I don't have a problem with. I only have a problem with the square root of 10. Right?
You didn't have to do that though. Like, so going back to your sign, you had to change it. You didn't have to change it for the secant. You could have just left it and flipped it. So like 3 is 3 over square roots of 10, but you have to change it. But that one you can just leave that as square roots of 10 over 3. You don't have to go through and multiply.
Did I? I don't think I rationalized him to get him better though.
You didn't?
Huh,
I thought
huh,
that was
huh,
what you did right there for sign.
So this guy, okay, so this guy would be 10 square roots of 10. The bottom, square root of 10 times square root of 10 is just 10, but I have that 3 there, so this is 30, yeah?
Okay.
And then what happens? I can divide by 10, so this 10 is gone, and this guy will just become 3, so this is the square root of 10 over 3.
So I
That's
got the same
disgusting.
thing.
Yeah, you get the same thing, but, you know. So there's that, okay? Then the tangent. Tangent is OA, opposite over adjacent. Opposite is, hey, this one's nice. Opposite is 3 square roots of 10. Adjacent is the square root of 10, yeah?
They cancel.
Those will cancel, so tangent is 3. What's the reciprocal of 3?
1/3.
1/3. That's really nice. Yeah, those
Which
are
do you
really
like
disgusting.
better? This guy? Or this guy? This guy?
This one's easier to read.
This one is easier
Yeah.
to read? Okay.
I don't know. Whichever one. Okay, good. Happy with that? That's 24. That had really ugly square roots and things in them. Don't put decimals in your answers.
Why not?
Just leave them as square
You did it
roots.
wrong if you left it at 90. She likes this.
No, sure.
You would have counted it wrong, right?
No. You can leave him. But going forward, reduce him down. Okay? That's 24, yeah? Are we ready to move on? In the notes, go to example 5. Go to example 5. That's where I think we kind of left off at. Example 5. And you need your unit circle, by the way. Simplify the expressions. We're just evaluating what these are. Okay? So grab your unit circle. Some of these are on, I think all of them are on your unit circle.
Can you give me 2
It's a good question.
Sure.
What is roll?
I think someone would.
Like, go on, just music. All yours.
What? Ready? Okay. Part A, tangent of 60. Find 60 degrees in your unit circle. It's in the first quadrant. Go. What is tangent of 60 degrees? It's like the square root of 3 or something. Yes, that's what I want. Tangent of 60. Okay, now find 30. Find tangent of 30 on your unit circle. The square root of 3 over 3? Okay. How do we put those two together?
Well, we probably have to find it.
This is going to test your algebra stuff. What's the denominator of this guy? 1. Okay, he is over 1. Put him over 1 to begin with, all right? What's my common denominator going to be? 3. So I have to multiply this guy by 3, but then I have to multiply the top guy by 3, right? So he has 3 square roots of 3 over 3. You got it? Yeah, so what's 3 square roots of 3 minus a square root of 3? 2 square roots of 3, right? Over 3. There you go. Do you see how we arrived at that? Find a common denominator. 3 square roots of 3 minus a square root of 3 is 2 square roots of 3? Yeah?
Yeah.
Yes.
And is it K-O, how do you spell the last name, S-S-E?
Okay, good. B. Sit tight with that 2. Let's do sine of pi over 6, right? Go to pi over 6 on your unit circle. Pi over 6 is in the first quadrant. He is 30 degrees, is what pi over 6 is. Sine. When you have x comma y, sine is the, which one?
Second one.
Second one. Sine is the y coordinate, cosine is the x coordinate. Okay, so what's sine at pi over 6? Half. Okay, so I've got the 2 just chilling. What's cosine of pi over 6? Square root of 3 over 2? Yeah? Okay, now what?
Distribute the 2.
Well, you don't distribute him like this through because he's not like, yeah. You see what I'm saying?
Just change them to
Yeah, you would just take like 2 times 1 or 2 times a half. You see what I'm saying? That's just going to cancel. So the answer is just square root of 3 over 2. Do you see why we don't distribute? Square root of 3 over 2? Good? We are on example 5. Part B. We just got done with part B. Okay? Those are just simplifying. You're just going to try to get like a reduced angle or a reduced value. Got it? Okay? We know these already. Use fundamental trig identities. So this little box right here, it talks about which ones are reciprocals. So cosecant and sine are reciprocals. Secant and cosine, cotangent and tangent. Those are reciprocals. Also, put a little star by this guy. Tangent is sine over cosine. We've talked about him before, but make sure you know it. Tangent is sine divided by cosine. Now, cotangent is cosine divided by sine. So you could flip those two around, right? Okay? They're talking about reciprocals. They're reciprocals, reciprocals, reciprocals. Okay? These are ones that we've already had, like Pythagorean identities. We said sine squared plus cosine squared equals 1. And then these are just like derivatives of that. So tangent squared plus 1 equals secant squared. 1 plus cotangent squared equals cosecant squared. I do not have these two memorized, but I have this first one memorized because we use them a lot. Okay? So I don't expect you to memorize all three of them, but kind of maybe probably memorize the top one. Sine squared cosine squared equals 1. That one's not too hard. Okay? Now, also, really quick, off to the side over here. Are you guys watching? Everybody watch. Sine squared plus cosine squared equals 1. Ready? What if they say 1 minus cosine squared?
Sine squared.
Equals sine squared. Like, I can move this stuff around, right? Like, if I subtract cosine squared from both sides, I could get 1 minus cosine squared, and that's equal to sine squared. Do you see how this works? So I can move that stuff around. Like 1 here is equal to secant squared, and then what? Minus tangent squared, right? I can move stuff around, okay? This would be 1 equals cosecant squared minus cotangent squared, etc. I can move stuff around however I want. Does that make sense? Okay? Or maybe I'm solving for cotangent squared in this bottom one. Maybe I'm solving this guy. So this guy is equal to this guy minus 1. Do you see how that works? Okay? I can move all that stuff around however I want. Got it? Okay? All right, let's go down here and let's do, I don't want to talk about those yet.
Just ignore them.
Find a cofunction with the same value. I'm going to skip example 6 because I don't want to talk about it yet. Let's go to example 7 and 8.
What if we have some of those in our homework?
You don't. I didn't give you any of those. I promise you I didn't. Okay? All right. These are the story problems. You're going to like these because these are what we typically do with SOHCAHTOA story problems, okay? All right. One thing before we do the story problem. Horizontal, straight out in front. An angle of elevation is taking that and elevating it, right? So the angle of elevation is up. You're so funny, Hitler. Angle of depression is going down. It's the angle that's making going down, okay? Jeez. You guys don't listen to anything else I say, and then the second I put my hand in the air, you're like, oh my gosh, okay, whatever. Anyway, angle of elevation and an angle of depression. Do you see how that works? Okay? Now, sometimes they will do this to you, okay? So sometimes they'll talk about this in terms of like the sun. So here's the sun shining, and it's casting a shadow, blah, 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 whatever, right? Okay? Sometimes, check this out, they will talk about this angle, or they will talk about that angle. Okay, so like this blue one right here versus this one right here. They're going to be the same, Billy says. Why? They are not corresponding.
Alternate interior.
They are alternate interior angles, right? So just keep that in mind. You have your parallel lines right here. These two angles will be exactly the same, right? Like those two values, okay? So sometimes they'll give that to you. All right, here we go. Example 7, using trig to find the height of a tree. Palm trees are easy to transplant relative to similarly sized broad-leaved trees. Because they're like the base of a palm tree is not as big and it probably doesn't have as many roots and stuff going out. So at one tree farm, palm trees are harvested once they reach a height of 20 feet. Suppose that the distance along the ground from the base of the tree to a farm worker is 22 feet, blah, blah, blah. Is the tree tall enough to harvest? All of this good stuff. Okay, so we're trying to find the height of the tree. They're harvested at how tall? 20 feet. So I want to see if this is 20 feet. Is it 20 feet?
I could have done this before.
Question mark. Let's figure it out. Okay, so what are we going to do? 30.2 is here. I'm looking at this right triangle. Right there. I'm looking at that right triangle. This is 22 on the bottom. Yeah? So I'm trying to find like this thing right here. We have to use SOHCAHTOA, right? Okay? So in particular, the angle that I have is 30.2. The question mark is the opposite side, yeah? What about 22? That is the adjacent side. So which trig function are you going to use?
Inverse tan.
We're going to use tangent. Tangent of what? What goes inside of tangent?
30.2.
30.2. Do we remember this from algebra? Right? Equals. We don't know what this is, so let's call it x. We don't know what that is, so we'll call it x. Tangent is opposite over adjacent. So does the x go on the top or the bottom?
Top.
Top, because it's opposite. Opposite over adjacent. So x over 22.
Times 22.
Now if I'm trying to find x, I multiply the 22 over. Am I going too fast? Is this making sense?
You're good.
We're good? X equals. Now, hold up. Wait a second.
I was gonna do it.
Wait a second.
That's before.
Do you want to have your calculator in radians or degrees, or does it matter?
Degrees.
Does it matter?
It does matter.
It does matter.
Because we're in degrees right there.
30.2 is a degree measurement, so you need to make sure your calculator is in degrees right now. So, click your calculator, go to mode, make sure he's in degrees, take 22 times tangent of 30.2, what do you get?
It is 12.8.
It is 12.8,
And then we
okay?
need to add 6.
Now, 12 is only from here to here. 12.8, we need to add 6, so how tall is that tree?
18, not good.
18.8 feet. So, is the tree tall enough to harvest?
Absolutely.
Not tall enough. Do you guys remember doing this? Like from geometry, like this was, did we do it in geometry and algebra 2? We do it in algebra 2? A little bit, like right at the end of the year, we did a little bit in algebra 2.
Okay.
But not a whole lot.
Whatever you say,
Okay.
Mr.
Whatever I say. All right. I like that. You should say that again. Whatever I say, Mrs. Cumminger, right? Okay, example 8. Very nice. That's cute. I like it.
So good.
Okay. All right, example 8. A pilot is flying an airplane at an altitude of 1 mile. Okay, that means the altitude straight down. Hey, geometry kids, we just got done talking about altitude. Altitude measures straight down to like sea level, right? Altitude. 1 mile in the air. This is like that side of my right triangle. Okay. Sights a point at the end of a runway and the angle of depression is 3 degrees. What is the distance from the plane to the point on the runway? So I'm trying to find like this distance right here.
Which one?
Ugh. But like the 3 degrees is not even in my triangle.
We know the bottom one's 3.
We know the bottom one's 3. We just got done talking about that, right? 3 degrees, yeah? So I'm trying to find this measurement right here, like the slope of him,
So
right?
opposite and hypotenuse.
Opposite hypotenuse, right? Opposite hypotenuse. So I'm going to use sine of what?
1 over h.
Sine of, what goes inside the sine?
Oh,
3.
3 equals
1 over.
opposite over hypotenuse. So 1 over d. And then I'm going to multiply by d to the other side. Right? And then divide by sine of 3. Or like Mr. Muth says, you can just swap those two around. Right?
1 divided by sine.
1 divided by sine of 3. Do you need to be in radians or degrees?
Degrees.
Degrees. 3 is a degree measurement.
19.1.
19.1. What units are we in?
Miles.
Miles. We're in miles. Yep. 19.1 miles. Okay, now hold up real quick.
I don't know if that's right.
Hold up real quick. One more thing. This is 3 degrees. What's this little angle right here?
87.
He is 87. Could I have done cosine adjacent hypotenuse but with 87 degrees? Like cosine of 87 is equal to 1 over d, right? And done d equals 1 over cosine 87. Could I do that as well? And you would still get 19.1? Yes, you would. Okay? So don't think you have to do it a certain way. If your brain works in doing this angle rather than the 3 degrees, totally fine. You just would do cosine instead of sine. Got it? Yeah, we like a lot of those, right? Like those are not too bad. Okay? Good, good? This is like the nice stuff. Right triangle trig. We like it a lot. It's a lot better. Okay?
We're done, right?
We're done. That's all.
Can you send
Okay.
us the notes?
I can't. Yeah. We didn't really do a whole lot. Like we just did a few.
We didn't do 6.
Here's the homework. There's the homework. You should be able to do all of them now. 36, 52, 56, 58, but some of them have like multiple parts to it, so be careful. This is 4-3. There he
We
is.
didn't do 6, right?
What?
No example 6.
No, example 6.
Yeah, we skipped example 6 and then we did all the rest of them. So.
We did 7? 2?
What are you doing here? Oh my gosh. Okay, I'll stop recording. Malia just lost a tooth. All right. Goodbye.